Okay, so hello everyone. Today, so I'm Shrija Ghosh. I'm a PMRF from IIT Kanpur, and this is the second week of the problem solving session for the course Environmental Chemistry and Microbiology. The course instructors for this course are Professor Anjali Pal and Professor Sudha Goel. You must have attended their lecture videos, so I'll be helping you solving the second week assignment by solving some related questions. Okay, so in the second week the lecture videos are all about equilibrium. So we have certain questions which are related to your assignment questions, and we'll see how to solve them. Fine. So you'll just wait for 1 more minute and then we'll start. Okay, so we'll start now. So the first question in this week's problem solving session is: consider a gas phase reaction N2 plus O2 gives 2NO, that is nitric oxide, plus heat. When the pressure is increased, then the equilibrium constant will. So here our question is, we have a reaction given. It's a equilibrium reaction. I hope you have seen the lecture videos, so you know what kind of reaction. It's a reversible reaction, so it can go both ways. And now we can see there is the factor heat is there. That means it's an exothermic reaction. That means heat is being released along with the product. In the forward direction, the heat is being released. So it is an exothermic reaction. Okay. Now what is the question? If they increase the pressure, then the equilibrium, what changes will be there in the equilibrium constant? So anyone can answer this question. Just take a guess if you don't know. Anybody? Hello. If we increase or decrease the pressure, what will happen to the equilibrium constant? That is the question. Okay. So what is equilibrium constant? Equilibrium constant means, how do you define equilibrium constant in terms of formula? K is equal to the product concentration divided by the product. Sorry.
Reactant concentration.
Yeah, reactant concentration. So so in this question, if we increase the pressure, now all of them are in gas phase, what will happen to the equilibrium and what will happen to the equilibrium constant? So if we increase the pressure, the equilibrium constant will remain unchanged. Why? Because this is a constant. So what happens during equilibrium? Rate of forward reaction is equal to the rate of reverse reaction. Okay. So in any case, even if you change the pressure, if you increase the pressure or if you decrease the pressure, the final equilibrium constant will remain the same. It will remain unchanged. Okay, do you understand? So what happens during equilibrium? Only the rate of forward reaction and rate of backward reaction are equal. It's not that the concentration of the reactants and concentration of products are equal. Okay, so this is the first major thing that you have to clarify, that you have to understand very clearly, that during equilibrium you don't have equal amounts of left hand side and right hand side compounds. So during equilibrium only the rate of forward reaction and rate of backward reaction, they become equal. Okay, so the amount of product that will be formed from the forward reaction will be same as the amount of the will be same as the reverse reaction. So how much ever you will the nitric oxide will form, same at the same rate it will decompose into nitrogen and oxygen gases also. Okay, so there won't be any change in the equilibrium constant. Okay, so equilibrium constant will remain unchanged. Okay, so coming to question number 2, what is the minimum concentration of SO4 2 minus that is required to precipitate Pb2 plus as PbSO4 from a 0.01 molar PbNO3 whole twice? The Ksp for PbSO4 is 2.2 into 10 raised to the power minus 8. Now what is Ksp? Anybody? If you have attended the lecture videos, if you have seen the lecture videos, you must have.
Solubility product
Yeah,
constant.
yeah, it is the solubility product. Okay, and in this question what is happening? The PbSO4 is getting precipitated out of the PbNO3 whole twice solution. Okay, lead nitrate, lead sulfate is getting precipitated out of lead nitrate. Why this is happening? So this phenomena is called common ion effect. So in both lead sulfate and lead nitrate you have the lead ion as the common ion. Okay, so what will happen when you keep adding the common ion that is present in the solution, the salt, the lead sulfate will start precipitating out of the solution. Okay, so its solubility will decrease to a point where it will precipitate out of the solution. Okay, so now what we have asked, how much SO4 2 minus is required to precipitate this out. Okay, so now we have to find the concentration, the amount of sulfate that is needed to precipitate lead sulfate out of the lead nitrate solution. Okay, so for this we have the solubility product given as 2.2 into 10 raised to power minus 8. So how will we solve it? We know that solubility product is nothing but the product of each ion that is present in the salt to raised to the power of number of moles that are present. Okay, so in this case PbSO4 will dissociate into Pb2 plus and SO4 2 minus. Okay, 1 mole of Pb2 plus 1 mole of SO4 2 minus. So solubility product can be written as Pb2 plus concentration multiplied by SO4 2 minus concentration. Okay, and now the value of solubility product is already given. What else do we have in the question? We have the value of lead ion. If you see in the question you have the concentration of lead nitrate. Okay, so what will happen when you will keep on adding the lead sulfate, since the Pb2 plus ions are common, it will precipitate the lead sulfate out of the solution. Okay, so what is the common ion concentration? If you see PbNO3 whole twice, Pb2 plus 1 mole of Pb2 plus is there, what is the concentration? The concentration of PbNO3 whole twice and Pb2 plus will be same, because 1 mole of PbNO3 will give 1 mole of lead ion. Okay, so the concentration of Pb2 plus will also be equal to 0.01 molar. Okay, so we have the concentration of Pb2 plus, we have the Ksp value. What do we have to find? We have to find the sulfate concentration. So it is simple, you just divide the lead concentration by the solubility product. So 2.2 into 10 raised power minus 8 divided by 0.01, just solve it, you will get 2.2 into 10 raised power minus 6. So the concentration of sulfate, that should so in the question we have been asked the minimum concentration. So minimum concentration should be 2.2 into 10 raised power minus 6. So whatever, if you add any concentration which is higher than 2.2 into 10 raised power minus 6, your lead sulfate will get precipitate out of the solution, as the solubility of lead sulfate will decrease. Okay, I hope this question is clear. Those who have entered right now, you can see the question was minimum concentration of sulfate that is required to precipitate lead ions as lead sulfate from a solution of lead nitrate, and the solubility product was given. So your lead sulfate will dissociate into lead ion and sulfate ion separately, and the solubility product can be written as the product of the concentration of lead ions and product of the and the concentration of the sulfate ions. So it is equal to the value of 2.2 into 10 raised power minus 8. Then we have the value of lead ion concentration, we just have to find the sulfate ion concentration. Whatever value you will get, that will be the minimum concentration of sulfate. Anything higher than this will precipitate lead sulfate out of the solution. Okay, so if we see which option is correct, our option number B is correct. Okay, in the question option number B is correct. Fine. So moving on to the next question. Question number 3. In the following reversible reaction, HCOH, which is formic acid, gives formate ion and proton H plus. Okay, at equilibrium the addition of H plus would cause. So what will happen if we add more H plus ions once the equilibrium has been achieved? So I have told you what do you mean by equilibrium? When the rate of forward reaction is equal to the rate of reverse reaction. Okay, so once both the rates are forward and reverse reaction rates are equal, so what will happen? How much ever formic acid is dissociating, that amount will that same reaction, the formate ion and proton will attach and form the formic acid in the same rate. Okay, so if we add H plus ions, that means we are increasing the concentration of the right hand side contents. Okay, so what will happen if I increase the H plus ion concentration? What will happen? More and more formate ion will be consumed. Okay, if everything is at a constant rate, if everything is at equilibrium, what will happen? At that time everything is at a steady state. Now if I suddenly add some H plus ion, so H plus ion is in excess now, so those H plus ions will start neutralizing the HCO minus, and the reaction will go backwards. Okay, the reaction will start going backwards so that again equilibrium is achieved. Okay, so the answer for this question will be decrease of HCO minus ion concentration. Okay, so at equilibrium the increase of H plus ion would shift the equilibrium in the left hand side, towards the reverse reaction. Okay, so the HCO minus concentration will decrease. I hope this question is clear. So the answer for this question will be option number B. Okay. So moving to the next question, question number 4. Calculate the approximate pH at which FeOH whole thrice ferric hydroxide gets precipitated if concentration of ferric ions is 10 raised to the power minus 2 molar and value of Ksp for ferric hydroxide is 3.8 into 10 raised to the power minus 38. So what do we have in this question? We have the solubility product. We have already solved this kind of question right now. The question number 2 was similar to this. So what do we have? We have the Fe3 plus concentration and we have the solubility product. How will we define solubility product for FeOH whole thrice? Can anybody answer? What will be the Ksp? How will you write in terms of concentration of each ion? Ksp will be equal to concentration of Fe3 plus
Fe3 plus and
yeah,
OH minus.
only OH minus. How many moles of OH minus will be released when FeOH whole thrice will be dissociated?
3 moles.
3 moles. So it will be OH minus ions to the power of 3. Okay. So solubility product, whenever you are writing solubility product, FeOH whole thrice, it will dissociate into Fe3 plus 3 OH minus ions. Okay. So if I have to write the solubility product in terms of concentration of each ion, it will be the concentration of Fe3 plus multiplied by the concentration of OH minus ions 2 raised to the power 3. From where this 3 is coming? Number of moles. So if there were 2 moles of Fe3 plus, this also would have been raised to the power 2. Okay. So whatever the number, so if you have any salt AB, if it is dissociating into n moles of A and m moles of B, so your solubility product will be A to the power n and B to the power m. Okay. So solubility product, always you have to consider the number of moles of each ion that is coming out of the salt. Those number of moles will go in the power of the concentration. Okay. So now Ksp is defined as Fe3 plus concentration into concentration of OH minus ions to the power 3. Now what do we have in the question? We have the Fe3 plus concentration given. Okay. The Fe3 plus concentration, how much Fe3 plus concentration is given? It is 10 raised to the power minus 2 molar. Okay. So Fe3 plus concentration is 10 raised to the power minus 2 molar, and what did they ask in the question? They have asked the pH, approximate pH. So from this equation, Ksp is equal to Fe3 plus concentration of Fe3 plus into concentration of OH minus raised to the power 3. What we can find? We can find the OH minus ion concentration. Okay. So we have the Fe3 plus concentration, let the OH minus ion concentration be Y, so it will be Y cubed. So if you will solve this, this is 3.8 into 10 raised to the power minus 38, that is the KSP value, is equal to 10 raised to the power minus 2 into Y cube. So what will be the Y cube value? Y cube will be 3.8 into 10 raised to the power minus 36. Okay. And when you will take the cube root of that to solve for y, you will find the value to be 1.56 into 10 raised to the power minus 12. Fine. This much is, I hope this much is clear. Now, in the previous week session also we had discussed, if you have OH minus ion concentration and if you have to find the pH, how will you find? We just have to find the pOH value first and then we will find the pH. Okay. If we have OH minus ion concentration given, how will you find pOH? To find pOH, we will just take the negative logarithmic of OH minus ion. Okay. So, negative log of 1.56 into 10 raised to the power minus 12. Now, I have told you earlier in the previous session how to solve for this logarithmic equation. So, this will be minus log of 1.56 plus minus log of 10 raised to the power minus 12, which will eventually be 12, and then minus log of 1.56, whatever the value will be. When you will solve this whole thing, the final answer comes out to be 11.8. Now, this is not our final answer. In the question, we have been asked to calculate the pH. What we have calculated is pOH. pOH is 11.8. Now, we have discussed in the previous session how to find pH from pOH. So, to find pH from pOH, we have to subtract pOH from the Kw value, the dissociation constant for water. What was the Kw value? It was equal to 14. So, if we have to find the pH from pH value and if we have the pOH value, we just subtract 14 minus 11.8 and the answer is 2.2. So, pH is equal to 2.2. So, we will see which option is correct in the question. Option number A is the correct answer. Okay. Any doubt in this question? I hope this was clear. So, question number 5. When you titrate KCl solution taken in a conical flask with AgNO3 solution taken in a burette, colloidal AgCl is formed. The AgCl formed in aqueous medium may be positively or negatively charged with adsorbed ion. The ions may be. So, what is happening? We have a KCl solution in a conical flask and we have a burette attached to the stand above this conical flask in which we have taken AgNO3 solution, silver nitrate solution. Okay. And we will keep on adding drop by drop the silver nitrate solution to the potassium chloride solution. And what will happen? The silver ions will displace the potassium ion and silver chloride will form. Okay. Colloidal silver chloride is formed. So, they have asked which ion will be adsorbed on the AgCl colloidal particle. So, how to determine this? So, if you would have seen in the lecture video also, it has been explained in the formation of in this phenomena, colloidal formation, what happens is whatever is in excess. So, what do we have in excess? We have KCl in excess because it is in a flask. What is the limiting compound here? AgNO3, silver nitrate. We are adding silver nitrate from a burette. So, we will keep on adding it drop by drop. So, what will happen when you keep adding AgNO3? So, what all ions are there? First, we will see. We have potassium ions, we have chloride ions, we have silver ions Ag plus and we have nitrate ions. Okay. All these ions are there. So all of these are an option. So how do we find? So first thing you have to remember is any colloidal particle will absorb its own ions. Okay, so now it is AgCl particle. Okay, colloidal AgCl is formed. So AgCl will either absorb Ag plus or Cl minus. Okay, this thing you have to first put in your head. So if you have Ag plus and Cl minus, now what do you have in excess? Ag, this silver nitrate we are adding from burette, so it is limiting. So whatever Ag plus ions will be there, they will just displace this potassium ion and attach with chloride ions to form the silver chloride. So but in the solution we have chloride ions in excess. So the chloride ions will get absorbed in the on the AgCl colloidal particle. Okay, so what will happen? The answer will be option number D, chloride ions. Why? Because colloids always absorb uh, only their own ions. So if it is a AgCl colloidal solution, what will happen? It will only absorb either Ag plus or Cl minus. What now from these two options, Ag plus and Cl minus, we have Cl minus in excess, so that will get absorbed. If we had the other way, if the question was other way round, and if we had Ag plus in excess, Ag plus would have gotten absorbed. Okay, so you just have to see, you just have to understand which one is in excess, and that particular ion will get absorbed on the colloidal particle. So answer will be chloride ions, that is option number D. I hope this question was clear. So coming to the next question, question number 6. Silver chromate dissolves in water to the extent of 0.049 grams per liter at 25 degrees Celsius. Estimate its approximate solubility product. Molecular weight of silver chromate is given. So silver chromate, that is Ag2CrO4, its solubility is given, but the solubility is given in terms of gram per liter. Okay, and at the particular temperature. So temperature is always important in these all the questions related to equilibrium, because equilibrium is always temperature dependent. Okay, so at 25 degrees Celsius, the solubility of silver chromate is given to be 0.049 grams per liter. Now in the previous class also I have explained how to calculate molarity from grams per liter. Can anyone answer? How will we, if for KSP calculations we need the values to be in molar. We need the values to be in molar concentration. So what will be the value in molar? How will we calculate the value in
We can
molarity?
divide by the molecular weight.
Yes, we have to divide by molecular weight. So 0.049 grams per liter divided by the molecular weight, that is 331.73. It can give us the value of the concentration in terms of molarity. So we will see what is happening. So we have silver chromate Ag2CrO4. So it will dissociate into 2 moles of Ag plus and 1 mole of CrO4 2 minus. Okay. So 2 moles of Ag plus and 1 mole of CrO4 2 minus. Now let S be the solubility of the silver chromate. So if S is the solubility of silver chromate, then what will be the Ag plus concentration? The Ag plus concentration will be 2S, because 2 moles of Ag plus, 1 mole of silver chromate is giving 2 moles of Ag plus. So if the solubility of silver chromate is S, the concentration of Ag plus will be 2S. Okay, the concentration of CrO4 2 minus will remain S, because 1 mole of silver chromate is giving 1 mole of chromate ion. Okay, So now how do we define KSP? KSP is the product of the concentration of each ion raised to the power the number of moles. So it will be Ag plus concentration raised to the power 2 into CrO4 2 minus concentration raised to the power of 1. So Ag plus concentration is 2s, so 2s raised to the power 2 into s raised to the power of 1. So if you solve this, you will get KSP is equal to 4s cube. So KSP is equal to 4s cube. Now what is the solubility? Solubility, we have the solubility in terms of gram per liter, 0.049 grams per liter. So we divide it by the molecular weight to get the solubility in terms of moles per liter. Okay, molarity. So you divide this 0.049 by the molecular weight, that is 331.73. So this will be the value of S. Okay, so value of S we have. Now S was equal to the concentration of chromate ion also, and the concentration of silver ions was 2s. So accordingly you can calculate both, and to find the KSP you just have to do 4s cube. So 4 into cube of this whole thing. Okay, so once you solve the whole thing, you will get the answer to be 1.27 into 10 raised to the power minus 11. Okay, so if you solve this using a calculator, you will find the answer. So we have the value of S to be 1.47 into 10 raised to the power minus 4. So if you take the cube of this, multiply it 3 times and then multiply it by 4, you will get the answer to be 1.27 into 10 raised to the power minus 11. So we will see which option is correct. The option number C is correct. Okay, the option number C for this question is correct answer. I hope this question was clear. We'll move to the next question now. Option number C for this question. Okay, so moving to the next question, question number 7. A reaction is in equilibrium. At constant temperature, when the concentration of reactant is increased, then the equilibrium constant of the reaction at equilibrium will. Now again, reaction is in equilibrium. What does it mean? The rate of forward reaction is equal to the rate of backward reaction. Now at a constant temperature, if you keep on increasing the reactant, what will happen to the equilibrium? Equilibrium will shift towards the product. For the for maintaining the steady state, if you increase one side, that side will go to the opposite side to make everything steady. Imagine it like a seesaw. Okay, so if you put weight on one side, the other side will go up till both the sides are equal. Okay, imagine a weighing scale or something. Okay, so it's like that. So if you put increase the reactants, the equilibrium will shift towards the product, towards the forward reaction. But in the question we have been asked, what will happen to the equilibrium constant? So what will happen to the equilibrium constant? The equilibrium constant will not change, because it's the equilibrium that is changing. It is the rate of reaction that is changing. But sorry, it is the direction of reaction that is changing. But when you take the ratios of the forward and reverse reaction rates, it will always be constant. Okay, so changing the concentration of reactants is not going to affect the equilibrium constant of a reaction. Same thing we have discussed in question number 1. Changing the pressure will also not change will not change the equilibrium constant of a reaction. Okay. constant temperature, the equilibrium constant does not change with the increase of reactant concentration. Okay. So when does the equilibrium constant changes? It can change only with the change in temperature. That's why always the temperature factor is mentioned, because at different temperatures the equilibrium constant will be different for a particular reaction. Okay. Okay, moving on to the next question. Question number 8. The solubility of a sparingly soluble salt, silver chromate, is 7.5 into 10 raised to the power minus 5. Calculate the approximate solubility product of the salt. Again, similar kind of question. I would like all of you to solve this question, because we have already discussed this question, this kind of question. So we have silver chromate. So 2 ions will be coming out of silver chromate. One will be silver ion, one will be chromate ion. We have the solubility value given. We have to find the solubility product. So how will you find the solubility product? What will be the KSP value? How will you define the KSP value? Let's say solubility of silver chromate is S. Then what will be the KSP value? Anyone can answer? If the solubility of silver chromate is S, what will be the... Yeah. Yeah, who was answering?
So I think 2 Ag is present and 1 CrO4.
Yes.
So is it 2S square into S equal to the given value 7 point?
Yes. Yes. So it will be
2S square into S. That means 7 point. In place of S, we will take 7.5 into 10 to the minus 5.
Yes. Yes. Exactly. So what is happening? We have Ag2CrO4. So 2 Ag plus ions and 1 CrO4 2 minus ion. Okay. 2 moles of this and 1 mole of this. So if the solubility is S, if the solubility of silver chromate is S, then what will be the concentration of Ag plus? The concentration of Ag plus will be 2S, because 2 moles. Okay, 1 mole of silver chromate is giving 2 moles of Ag. So concentration of Ag plus will be 2S. 1 mole of silver chromate is giving 1 mole of chromate. So the concentration of chromate ion will remain S. So solubility product, how do we define solubility product? Concentration of each ion to the power of the number of moles, product of concentration of each ions to the power of the number of moles. So Ag plus concentration to the power of 2 and CrO4 2 minus concentration to the power of 1. So Ag plus concentration is 2S. So 2S square, 2S whole square. So 2S whole square means 4S square. Okay. So that pay attention on that also, because a lot of times people forget to put the brackets and you can make a calculation mistake here. So this will be 2S whole square into S. So which will, if you solve this, it will be 4S cube. Now what was the value of S given? The value of S was 7.5 into 10 raised to the power minus 5. So you take the cube of 7.5 into 10 raised to the power minus 5 and multiply it by 4. So if you solve this whole thing, you will find the KSP value to be 1.687 into 10 raised to the power minus 12. Okay. So we will see which option was correct. Option number A was the correct answer. Okay, option number A was the correct answer for this question. Solubility. So we had the solubility value, we had to find the solubility product. Okay, this is simple. moving to the next question, question number 9. Solubility product of PbI2 is 8.5 into 10 raised to power minus 9. Its solubility is approximately. Now it's the opposite kind of question. In the previous question we had the value of solubility given, we had to find the solubility product. In this question we have the value of solubility product given, we have to find the solubility. We will use the same approach. Okay, so now PbI2, what will be the two ions that will dissociate from PbI2? What are the two ions? And along with the number of moles, what will be the equation? PbI2 goes to,
It will be Pb and 2 moles of
so
iodine.
Pb2 plus 2 I minus, okay, iodine. So it will be iodide ions, okay, and lead ions. So PbI2 goes to Pb2 plus 2I minus. Now again same approach, if the solubility is S, now Pb2 plus 1 mole of PbI2 is giving 1 mole of Pb2 plus, so the concentration of Pb2 plus will also be S. 1 mole of PbI2 is giving 2 moles of I minus, so the concentration of I minus ions will be 2S. Okay, and again now you have to write the solubility formula for solubility product. So it will be concentration of lead ion multiplied by the concentration of iodide ion raised to the power of 2, because 2 moles. Okay, so S into 2S raised to the power of 2, that will be 4S cube. So if we have the value of KSP given and we have to find the value of S, what do? We just divide KSP by 4 and take the cube root of it. Okay, so KSP is 8.5 into 10 raised to power minus 9 divided by 4 and the cube root of it. If you solve this whole thing, just divide 8.5 by 4 and then you can just take the cube root of that, and cube root of 10 raised to power minus 9 will be 10 raised to power minus 3. So if you solve the whole thing, you will find the answer to be 1.28 into 10 raised to the power minus 3. Okay, so that is the option number D, 1.28 into 10 raised to the power minus 3. I hope this question was clear. All the questions are very similar, and in your assignments also you will find similar questions only. So if there's any doubt you can ask. I hope it's simple. You just have to see what is given in the question and accordingly you try to solve the solution. So if your solubility product is given, you write, just expand whatever salt is given, just expand the reaction, just write the ions with the number of moles, with the particular number of moles. So whatever, so if I have PbI2, just first thing you think of which ions are coming out of PbI2. So Pb2 plus and I minus, 2 ions. How many moles of Pb2 plus? 1 mole. How many moles of I minus? 2 moles. And then once you have the equation, you can easily write the solubility product in terms of solubility or in terms of concentration of Pb, in terms of concentration of the ions, whichever is given in the question. So if in the question solubility is given or solubility is asked, you take solubility to be S and write it in terms of S. If in the question directly the concentration of the ions are given, it's simple, you just put the value of concentrations and just make sure you put the power right. So whatever number of moles of ions will be there, you just put the power to the concentration. So 2 moles of I minus means concentration of I minus to the power of 2. Okay, so I hope these questions are clear. We'll move to the next question. Question number 10. So what is the equilibrium constant of constant for a reaction R goes to Q plus half P if the equilibrium constant for the reaction P plus 2Q goes to 2R is 60. So now what is happening in the question? You see this equation and you see this equation. Do you see any similarity in both the equations? Just if you for once don't look at the number of moles, just see the reactants and the products. So in this equation for which the equilibrium constant is given, what are the reactants? P and Q. What is the product? R. Okay. And in this question, what are the reactants? R. And what are the products? P and Q. So if you see these two reactions are exactly same, just the direction has been reversed. Okay. I hope this is I hope you are understanding this. So P plus 2Q is 2R and R goes to Q plus half P. So this is, if you reverse this reaction, you will get this reaction if you don't consider the number of moles. But now we have the number of moles also here. So how will we find the equilibrium constant for this reaction? So for this reaction we have the equilibrium constant to be 60. So if I ask you to find the reaction equilibrium constant of the reverse reaction, how will you find? If I ask you to tell me the equilibrium constant of 2R goes to P plus 2Q, what will be the equilibrium constant in that case? Just the reverse reaction of this. If I invert this reaction,
1 by 60.
1 by 60.
1 by 60, right? So how are we getting that 1 by 60? Basically, how do we define equilibrium constant? It is the product of the concentration of products and divided by product of the concentration of reactants. So concentration of R raised to the power 2 divided by concentration of P into concentration of Q raised to the power 2. This value is 60. So if I have to find the value of, if I reverse this reaction, this will be basically inverse of the equilibrium constant. Now the reactants become the product and the product becomes the reactant. So the whatever reactants are there, now if this is the product, this will become the numerator and this will become the denominator. So if the equilibrium constant for the reaction P plus 2Q is 2R, P plus 2Q gives 2R is 60, the equilibrium constant for the reverse reaction will be 1 by 60. Till this point I hope this is clear. So once you have, see, so P plus 2Q gives 2R, the equilibrium constant is R square by PQ square, it is 60. So if you just invert this, the equilibrium constant becomes 1 by 60. Now if you see the
Yes, ma'am.
yeah, so if you see if in the equation, the equation for which we have to find the equilibrium constant, it is nothing but the half of this reverse reaction. So you have 2R goes to P plus 2Q. If you divide the whole thing by 2, so 2R by 2 will be R, 1 P by 2 will be 1 by 2P, and then 2Q by 2, that again 2 to cancel, so Q. So this is just the half of this reaction. Now for this, how will you write the equilibrium constant? It will be P raised to the power of 1 by 2, which is the square root, into Q divided by R. So if you see this equation and this equation now, okay, if you see P into Q raised to the power of 2 divided by R raised to the power of 2, and if you see P raised to the power of 1 by 2 into Q divided by R, you will see this is nothing but the square root of this. So if you just take the square root of 1 by 60, you will get the equilibrium constant for the reaction that has been asked. So the equilibrium constant for the reaction R goes to Q plus half P will be 1 by 60 raised to the power of 1 by 2. That is our option number C. Okay. This was a very simple question. You just have to see what has been asked and how it is related to what is given. So coming to the next question, question number 11. The reaction of H2 plus I2 goes to 2HI has a partial pressure of 0.326 atmosphere of H2, 1.625 atmosphere of I2 and 5.324 atmosphere of HI. Calculate the Kp for the reaction. So what is Kp? Kp is the equilibrium constant for pressure. Okay, so it is basically the pressure constant. So it is solved. It's the formula for Kp will be same as the equilibrium constant which we were solving in terms of concentration. So now instead of concentration, you just have to replace the value with partial pressures of each term. So partial pressure of the product raised to the power of number of moles, that is 2 in this case, divided by the partial pressure of the reactants raised to the power of their respective number of moles. So H2 plus I2 gives 2HI. So Kp will be partial pressure of HI raised to the power of 2 because 2 moles of HI are present, divided by partial pressure of H2 raised to the power of 1, only 1 mole, into partial pressure of I2 raised to the power of 1. Okay. So Kp is equal, now all the values are given, partial pressure of HI is given, partial pressure of H2 is given, partial pressure of I2 is given. You just have to solve the whole equation. So you take the whole square of this, you multiply these two, divide the whole thing, and you will get the final answer. The final answer is 53.5. When you solve this, you will get the answer to be 53.5. Okay, this was a very simple question. You just had to replace the values of the partial pressure in the formula. How will you write the formula? The formula is same as you write the equilibrium constant formula in terms of concentration. So in terms of concentration, equilibrium constant is equal to concentration of HI raised to the power of 2 divided by concentration of H2 into concentration of I2. Same thing, instead of concentration you have pressure, partial pressure of HI raised to the power of 2 divided by the partial pressure of H2 into partial pressure of I2. Okay. So answer is 53.5, which is option number A. Okay. I hope that was clear. Now moving to the next question, question number 12. The solubility of Mx, a sparingly soluble salt having molecular weight 170 in water at 25 degrees Celsius is 0.00179 grams per liter. Calculate the solubility product. Now solubility is given for the salt Mx. So it will be, so first of all, whenever this kind of question is there, first thing you do is write the equation. So Mx will go to M plus and X minus ions. Okay. Now the molecular weight of Mx is given. The solubility is given in terms of gram per liter. So again, first thing, solve for the molarity, because solubility, in terms of solubility product, you have to have the molarity value. So solubility to convert this gram per liter into moles per liter, you divide it by the molecular weight. So 0.00179 gram per liter divided by 170. Solve that, you will get the solubility of mx. Now once you have the solubility of mx, you have to find the solubility product. What will you take? Let the solubility of mx be S. Solubility of mx is S. So solubility product will be number of moles of m and number of moles of x. Both will be 1 and 1 because it is both the ions are in equal molar ratio. So m plus and x minus. So if you see, the solubility product will be the concentration of m plus, that will be S, and the concentration of x minus, that will again be S. So the Ksp will be equal to S square. Okay, and the value of S, how are we calculating? We are dividing it by the molecular weight. So 0.00179 divided by 170, that will be 1.053 into 10 raised power minus 5 molar. So this is the value of S. Our Ksp value is S square. So we have to take the square of this. So 1.053 into 10 raised power minus 5 whole square. If you solve this, you will get the answer to be 1.1087 into 10 raised power minus 10. So 1.1087 into 10 raised power minus 10, it is the option number C. Okay. I hope this was clear. So again, it was very similar to what we have solved previously. We have the solubility given, we have to find the solubility product. Okay. So all these questions are very similar. You just have to see what is given in the question and accordingly you try to solve the question. Okay. So you have whatever salt is given, first write the equation, see what all ions are there, how many number of moles are present, and then solve accordingly. Okay, so now we'll move to the next question. So question number 13. You are determining the hardness of a water sample by doing titration with sodium EDTA solution and using EBT. EBT is eriochrome black tea as an indicator. The stability of complex calcium EDTA is compared with the stability of calcium EBT complex. Which one of the following is true? So what happens? So if you would have seen in the lecture video, ma'am has explained this, how to determine the hardness of a water sample. So EBT, eriochrome black tea, it has blue color when it is not bound to any metal ion. Okay, and we use sodium EDTA to as EDTA is not very soluble, so to dissolve it we generally use the disodium salts of EDTA. Okay, so EBT, eriochrome black tea, it is an indicator, and when it is not bound to any metal ion, so in this case hardness of water generally it is given by in terms of calcium ions or magnesium ions. So we have to basically find how much of calcium ion is present or how much of magnesium ions are present. So for that we use this eriochrome black tea. So eriochrome black tea, when we add, whatever calcium ions will be there, they will get bound to the EBT, and it will change the color from blue to rose red. Okay, and then when you start adding sodium disodium EDTA salt, when you titrate it with EDTA. Since EDTA is more EDTA has a higher affinity towards calcium ions, towards any metal ions than the iriochrome black tea. So, EDTA will take all the calcium ions, bind to the calcium ions, and when all the calcium ions in the solution will be over, it will try to take the calcium ions that are bound to EBT, and there will be a very significant color change from rose red to blue. Okay, because calcium bound Ca2 plus EBT, this Ca2 plus EBT, it has a rose red color. And okay, so moving on to the question number 14. 3.3 moles of A are mixed with 5.5 moles of B, and mixture is then kept in 1 liter flask till the equilibrium A plus 2B gives 2C plus D is attained. At the equilibrium, 0.3 moles of C are formed. The equilibrium constant of the reaction is approximately. So, here in this question we have a equilibrium reaction where 1 mole of A is reacting with 2 moles of B to give 2 moles of C and 1 mole of D. Okay, and we have the initial amount of A and B present in the reaction, and after equilibrium we have the number of moles of C given for the reaction. So, we have to find the equilibrium constant. So, we all know how do we express equilibrium constant in terms of equation. It will be the product of the concentrations of the products forming raised to the power their respective number of moles divided by the concentration of the reactants raised to the power of their respective concentrations. So, basically we need to find the concentration of A, B, C and D at equilibrium to find the equilibrium constant. Okay. So, let us see how we will solve this. So, we have A plus 2B gives 2C plus D. Okay. And let us say the initial amount of A and B are small a and small b, and obviously at the start there won't be any reaction, so at the beginning the amount of C and D will be 0. Now at equilibrium, let's say X amount of A is consumed in the reaction. So the remaining amount would be A minus X. Okay. So since 1 mole of A is reacting with 2 moles of B, that means A minus, if X moles are getting consumed from A, double that amount will be consumed from B. So, if it is A minus X at equilibrium, it will be B minus 2X at equilibrium. Okay. So, this is A minus X, this is B minus 2X. Why 2X? Because if X moles of A is reacting, then 2X moles of B will react, because 1 mole of A reacts with 2 moles of B. Okay. Now, for the product, now if X moles are getting consumed, that means X moles are being formed in the product side. So, now we will see again the number of moles. So, 1 mole of A reacts with 2 moles of B to form 2 moles of C. Okay, 1 mole of A gives rise to 2 moles of C. So, X moles of A will give rise to 2X moles of C. Okay. So, if it is A minus X, this will be 0 plus 2X, because this is forming, this was getting consumed. Okay. So, 0 plus 2X, that is 2X, and 1 mole of A is forming 1 mole of D. So, it will be X only. So, 0 plus X, that is X. Okay. So, our final concentration at equilibrium for A, B, C and D are A minus X, B minus 2X, 2X and X respectively. Okay. So, now at equilibrium the amount of C is given as 0.3. That means the value of 2X will be 0.3 moles, right? So if we have the value of 2x to be 0.3 moles, the value of x will be 0.15 moles, okay? And we have the value of A and B given in the question, the initial concentration of A and initial concentration of B. So initial concentration of A is given as 3.3 moles and B is given as 5.5 moles. So we have the value of A, B and X. So now we just have to solve the equilibrium constant. How will we do that? So equilibrium constant for this reaction would be concentration of C raised to the power of 2 into concentration of D divided by concentration of A into concentration of B raised to the power of 2. So that means it will be 2x whole square, that is 2x into 2x multiplied by x divided by A minus x into B minus 2x whole square. Okay, just substitute the values of A, B and x and you will find the answer to be 1.585 into 10 raised to the power of minus 4. Okay, so this is basically 4x cube divided by A minus x and B minus 2x whole square. Okay, when you will solve this, you will find the answer to be 1.585 into 10 raised to the power minus 4, which is the option number B in this question. Okay, I hope this was clear. So moving on to the next question, that is question number 15. Calculate the solubility of silver carbonate. KSP of Ag2CO3 is given as 5.23 into 10 raised to the power minus 11. So now we have to find the solubility and we have been given the solubility product. So it's very simple. We have solved these type of questions right now. So I have told you how to find how do you define solubility product? It's the product of each ion of this concentration of each ion of the salt raised to the power of number of moles. So Ag2CO3, first of all we will write the equation of its dissociation. So Ag2CO3, what all ions it has? It has Ag plus ion and CO3 2 minus ions. Okay, 1 mole of Ag2CO3 will give 2 moles of Ag plus ions and 1 mole of CO3 2 minus ion. So if I have to write the solubility product, how will I write? It will be concentration of Ag plus raised to the power of 2 into concentration of CO3 2 minus. Okay, now let's say the solubility of silver carbonate is S. Then 1 mole of Ag2CO3 is giving 2 moles of Ag plus ions. That means the concentration of Ag plus ions will be 2S and concentration of CO3 2 minus will be S. Okay, so now if I have to write the solubility product, so I have told you it will be concentration of Ag plus raised to the power of 2 into concentration of CO3 2 minus. That means 2S whole square into S, which will be 4S cube. Now the value of 4S cube is already given as 5.23 into 10 raised to the power of minus 11. So we can solve for S, just divide it by 4 and then take the cube root of it and you can solve for S. And that is what we have been asked. So the value of S we are getting here after solving this is 2.35 into 10 raised to the power of minus 11. Minus 4. 2.35 into 10 raised to the power of minus 4. So that is option number B. So for question number 15, the answer is option number B. 2.35 into 10 raised to the power of minus 4. I hope this is clear. We'll move on to the next question now. Two moles of H2, 5 moles of I2 and 7 moles of HI are injected to 1 liter box, what would be the approximate concentration of I2 at equilibrium at 490 degrees Celsius? So, this is very similar to the question number 14 that we solved. Basically, we have the initial concentration of both products and reactants are given. Okay. So, basically, the reaction that is going on here is H2 plus I2 gives 2 HI. Okay. H2 and I2 reacts to form HI. At the same time, HI keeps on dissociating into H2 and I2. Okay, it's a equilibrium reaction. So when I am injecting all three components of the reaction, I am putting H2, I2 and HI in a box. What will happen? Both forward and reverse reaction will take place until the time the steady state is achieved, where the rate of forward reaction and rate of backward reaction will be equal. Okay. So, to solve this, first we have to write the equation. What will be the equation? H2 plus I2 gives 2HI. So, H2 plus I2 gives 2HI. So, what are the initial concentrations given? 2 moles of H2, 5 moles of I2 and 7 moles of HI. It is already given in the question. So, now what do we have to find? We have to find, first of all, we will solve for the equilibrium constant. The value of equilibrium constant is given. So, at equilibrium, what will be the final concentration? So, let's say X moles of H2 is getting consumed. Okay. So, X moles of H2 will be removed from 2. So, 2 minus X. Then, since 1 mole of H2 reacts with 1 mole of I2, so if X moles are getting reacted from 2, X moles will also get reacted from 5 as same amount of H2 will react with same amount of I2. 1 mole will react with 1 mole. So, X moles will react with X moles. So, the final concentration at equilibrium for H2 will be 2 minus X. For I2, it will be 5 minus X. For HI, it will be now whatever is getting consumed from H2 and I2, that is basically forming HI. So, there will be an increase in the concentration of HI. And how much increase will be there? 7 moles were there initially. So, it will be 7 plus 2x. Why 2x? Because 1 mole of H2 is forming 2 moles of HI. So, x moles of H2 will give 2x moles of HI. So, it will be 7 plus 2x. Now, if I have to write the equation for equilibrium constant, it will be 7 plus 2x whole square divided by 2 minus x raised to the power of 1 and 5 multiplied by 5 minus x raised to the power of 1. So, if you expand this, it will be a quadratic equation both in the numerator and denominator, and the value of equilibrium constant is already given. So, when you solve the whole thing, you will get a final quadratic equation and you can solve the value of x from that equation. Once we solve the value of x, the value of x is 1.48. So, what did they ask in the question? They asked us the approximate concentration of I2 at equilibrium. So, at equilibrium, the concentration of I2 is 5 minus x. Now, we have the value of x. So, what we have to do? We just have to subtract the value of x from 5. So, 5 minus 1.48 is 3.5 molar. So, if we see the answer, it is option number A, 3.5 molars. Okay. So, this was very similar. So, basically what we have to do is we have to write the equation and see what all is given in the question, and accordingly we have to see what will be the final equilibrium concentration of each component. Moving to question number 17. At what pH will AlOH whole thrice, that is aluminium hydroxide, begin to precipitate from 0.1 molar aluminium chloride solution? Ksp of aluminium hydroxide is given as 1.9 into 10 raised to the power of minus 33. So what is happening? Again, that common ion effect is happening. The aluminium ion is common and aluminium hydroxide will precipitate from aluminium chloride. So first of all we will see what all is given in the question. We have to find the pH. So for finding the pH in this question, we can find the OH concentration first. So we have the Ksp value given for aluminium hydroxide. So 1 mole of aluminium hydroxide will give 1 mole of Al3 plus ion, aluminium ion, and 3 moles of hydroxide ion. Okay. So we have the aluminium ion concentration. If you see, the concentration of aluminium chloride is given. Now whatever will be the concentration of aluminium chloride, the same concentration of aluminium ions will be present, because 1 mole of aluminium chloride is giving 1 mole of aluminium ion and 3 moles of chloride ion. So the concentration for aluminium ion will be same as the concentration of aluminium chloride. So that is 0.1. So we have the aluminium ion concentration. What we have to find? We have to find the OH minus ion concentration, that is the hydroxide concentration. So Ksp is equal to concentration of aluminium ion into concentration of hydroxide ion raised to the power of 3, because 3 moles of hydroxide ions are forming. So the concentration of aluminium ion is 0.1. The value of Ksp is already given. So if you solve this whole thing, you can solve for concentration of hydroxide ion. So once we have the concentration of hydroxide ion, what do we have to find now? So in the question we were asked to find the pH. So if I have the concentration of hydroxide ion, how do we calculate for pH? We will simply calculate the pOH first. So to calculate pOH, what will we do? We will take the negative logarithmic of OH minus concentration. So minus log of concentration of hydroxide ion, that is 2.66 into 10 raised to the power of minus 11. So minus log 2.66 into 10 raised to the power minus 11. If you solve this, you will find the pOH value to be 10.576. Okay. So pOH value we could calculate from here. Now again in the question we have been asked pH value. So how do we calculate pH from pOH? Basically pH plus pOH is equal to 14, which is the Kw value, the dissociation constant for water. So pH will be equal to 14 minus pOH. So 14 minus 10.576, which is equal to 3.42. Okay. So we will see option number A, 3.42 is the correct answer for this question. Okay. So moving on to the next question, that is question number 18. If in an endothermic reaction at equilibrium heat is added, in which direction the equilibrium will shift according to Le Chatelier's principle? So it's an endothermic reaction first of all. So what is the difference between endothermic and exothermic reaction? So in an endothermic reaction, basically the energy is consumed for the reaction to move forward. Okay, the heat is consumed in order to move proceed for the reaction, that in order to make the reaction go in the forward direction. In case of exothermic reaction, when the reaction moves forward, the heat is being released. So if you see it in form of a equation, basically the heat will be on the left hand side in case of endothermic reaction, and the heat will be on the right hand side in case of exothermic reaction. Okay, so this was your hint. Now if you have to solve this question, what will you say? Now if the heat is on the left hand side and I am adding more and more heat, what will happen to the equilibrium? The equilibrium will keep on shifting towards the right hand side, because now I have increased the left hand side concentration in a manner of saying. Okay, so the equilibrium will shift towards the forward direction. When the equilibrium will shift towards the forward direction, where it will go to the right hand side. Okay, so the answer to this question will be B, to the right. The reaction will move to that direction where the heat will be consumed. So where will the heat be consumed? It will consume towards the forward reaction. Okay, it's an endothermic reaction, so the heat will be consumed for the reaction to move forward. Okay, if it was an exothermic reaction, in that case, if you would have added heat, the reaction would have gone backwards towards the left hand side. Okay, so the next question number 19. Consider the following reaction. N2 plus O2 gives 2NO, nitrogen plus oxygen giving 2 moles of nitric oxide plus heat. The forward reaction will be favored by. So now it is same as the previous question, but the only difference is now what do we have? We have the heat on the right hand side. That means this is an exothermic reaction. Okay, so if it is an exothermic reaction, the forward reaction will be favored by what? We have to reduce the heat. We have to lower the temperature in order to move the reaction forward. So if we keep on increasing the heat, the reaction will go backwards, because in a way you are increasing the concentration at the right hand side. So to make it balanced, it will keep on moving towards the left hand side. Okay, so when you lower the temperature, in that case the forward reaction will be favored. So it is an exothermic reaction. So according to the Le Chatelier's principle, upon lowering the temperature, it will try to go to the forward direction. Okay, so now the last question of this assignment, question number 20. The solubility product of silver chloride is 5.3 into 10 raised power minus 14 at 25 degrees Celsius. Its solubility is approximately, given the molecular weight of silver chloride is 143.5. So we have the solubility product of silver chloride given. We need to find its solubility. So it's very similar to what we have solved till now. We have the Ksp value given and we have to find for S. Now 1 mole of silver chloride will give 1 mole of silver ions Ag plus and 1 mole of chloride ion Cl minus. So this is very simple. So if the solubility of silver chloride is S, what will be the concentration of silver ions? It will also be S, and for the chloride ions also it will be S. So if I have to write Ksp in terms of concentration, Ksp will be equal to concentration of silver ions multiplied by the concentration of chloride ions, that is S into S, that is S square. So you just have to take the square root of the Ksp value given in the question. Okay, so AgCl gives Ag plus and Cl minus. So Ksp will be concentration of Ag plus into concentration of Cl minus. So that is S square. So, the value of Ksp is given to be 5.3 into 10 raised to power minus 14. If you take the square root of it, the value of S will be 2.3 into 10 raised to power of minus 7. But now if you see in the question, the options are given in terms of grams per liter. So, we have what we have calculated the number of moles per liter. Okay, molar concentration we have calculated. So, from that molarity, if I have to find the grams per liter, how will we find? We have the molecular weight of silver chloride given in the question, that is 143.5. That means 1 molar silver chloride contains 143.5 grams per liter of silver chloride. So, 1 molar AgCl is equal to 143.5 grams per liter. So, 2.3 into 10 raised to the power of minus 7 molar AgCl will be 143.5 into 2.3 into 10 raised to the power of minus 7 grams per liter, that is 3.3 into 10 raised to the power of minus 5 grams per liter. Okay. So, if you see which option is correct, the option number B is the correct answer. Okay. So, this was the last question of this assignment. If you have any questions, you can write in the chat box. Thank you.